Let's go over common architectures that you would find PubSub within. So this is a common ingestion scenario. It starts with PubSub on the left. PubSub serves as the point where data is collected, stored, and buffered. This is an effective way to handle high volume real-time data ingestion, making sure that messages are not lost as they come into your environment. Next, the data flows into data flow, which is where the data transformation happens. Data flow allows you to apply transformations or cleaning to the data as it passes through. It's highly flexible and scalable, able to handle both batch and streaming data. After the data transformations are applied, the data gets routed to different destinations based on the type of data. For unstructured data, the data is stored in cloud storage, so it's good for files, logs, or media like images and videos. For relational data that requires SQL querying, the data would likely be sent to BigQuery, which is a fully managed data warehouse that excels in large-scale data analytics. For NoSQL, time series, or IoT data, the data would likely be stored in Bigtable, which is GCP's low latency, highly scalable NoSQL database, and it's good for real-time analytics and time series analysis. This is a common scenario. It demonstrates how GCP components can work together and move and process different types of data, ensuring that it's available in the right format and in the right place for further analysis or storage. And PubSub acts as the starting point for this entire process. It would be a good idea to memorize this pattern, or at least make yourself familiar with each of these services in order to know that they could fit together like this for certain business scenarios. And we will be covering the ones that we haven't yet, mainly data flow, in future sections. Now consider a scenario where you have a vast network of IoT devices, like thousands of tractors, wearable health monitors, smart home systems, or connected vehicles. These devices are constantly generating data that needs to be aggregated, processed, sent to the cloud for further analysis or storage. It would be convenient to have a piece of hardware or software in the middle that could collect all the data and send it to PubSub, right? So this tool in the middle that you can use for IoT devices is called an IoT gateway. The IoT gateway serves as a bridge between all your devices and cloud services like PubSub. It plays a critical role in collecting the data from all these devices and ensuring that it's processed and routed to the right destination. The gateway connects to PubSub. PubSub is the messaging backbone that buffers and distributes the data to other services like Dataflow, which we saw in the last slide, or BigQuery and cloud storage. It's important to understand the advantages an IoT gateway provides. That's data aggregation to collect and process data from multiple IoT devices, reliable transmission. The IoT gateway buffers the data locally and only sends it when a stable connection is available that prevents data loss. And with PubSub as the messaging backbone, your architecture can scale to handle large volumes of data from thousands or even millions of devices. This kind of setup could easily show up on the exam, so it's important to understand how IoT gateways work, their role in bridging IoT devices with cloud services like PubSub, and the benefits they provide for scalability and reliability in large-scale IoT deployments. Okay, those were a couple of common architectures that you could see with PubSub and could be tested on the exam.